Have you ever seen a headline about some big election poll or a massive public opinion trend and just thought to yourself, how could they possibly know that? I mean, how do they know what millions of people are thinking? It's a great question, and it gets right to the heart of how we understand our world. So let's dive in.
Seriously, think about it. It sounds kind of like magic, doesn't it? How can this tiny little group of people, maybe just 1,000 or so, supposedly represent an entire nation of millions? Well, I promise you, it's not magic. It's a really powerful scientific process called sampling, and honestly, understanding it is one of the keys to becoming a smarter consumer of information.
You might be wondering, well, why not just ask everyone? And the simple answer is, it's just not practical. At all. A full census, where you try to talk to every single person in a country, is unbelievably expensive and takes forever to complete. So researchers use a much smarter approach. They study a small, very carefully chosen group to learn about the whole.
Okay, so to really get this, we need to nail down two key terms. First up is the population. Now, this is the entire universe of people or things you're interested in. It could be all grade 11 learners in the country, or every single case of a particular virus, or even all the TV ads for a certain kind of product. It's the big, big group you want to say something about. And then you have this sample. This is the smaller, manageable group that you actually select from that population to study. The whole goal, the dream, is to choose this sample so carefully that it acts like a perfect miniature version of the population. That way, you can draw super accurate conclusions about the whole group by just studying a tiny part of it.
All right, so here's our roadmap for this explainer. We're going to start with the main problem researchers are trying to solve, then we'll look at the two major paths they can take, one that's all about chance and one that's driven by a specific purpose. And finally, and this part is so important, we'll get into the dangers and the things that can lead to really bad data.
And that brings us right to our first big topic, those two main paths. You can think of it like a fundamental crossroads. Every researcher gets here and they have to choose between two totally different ways of thinking about how to pick their participants. This one choice basically determines everything their study can and cannot claim. And this slide just lays it out perfectly. So on one side, you've got probability sampling. The key here is that every single person has an equal, known shot at being picked. The goal is to get a sample so representative that you can generalize your findings to the whole population. Then on the other side, you've got non-probability sampling. Here, the selection is deliberate. It's not random. The goal isn't to mirror everyone, but to get really deep, specific insights from a very particular group.
So let's walk down that first path, probability sampling. The whole idea here is to take human bias completely out of the equation and just let pure chance do the work. The main objective? To create a sample that is, for all intents and purposes, a statistically perfect little mini-me of the entire population you're studying.
Now, even in this world of pure chance, researchers have a few different tools in their toolbox. We're going to quickly look at 4 of the most common ones. You've got simple random, systematic, stratified, and cluster sampling. Each one uses randomness in a slightly different way to build that perfect miniature group.
Okay, the most straightforward method is pretty much exactly what it sounds like. Simple random sampling is basically the research version of drawing names out of a hat. You know, like a lottery fishbowl. Every single person in your population gets a number, and then you use some kind of random generator to pick your sample. It's the purest, most basic form of sampling by chance.
Systematic sampling adds a little bit of structure to the mix. So, you start with a complete list of everyone, maybe 10,000 people, and you decide you need a sample of 1,000. Easy enough. You just calculate your interval, in this case, 10. Then, you pick a random starting number between 1 and 10. Let's say it's 7. And from there, you just select person number 7. Then number 17, then 27, and so on, all the way until you have your full sample. It's random, but with a nice orderly system.
Now this one is really clever. What happens if your population has these really important subgroups that you absolutely have to make sure are represented? I mean, with a simple random sample, you might just by pure bad luck miss out on a small but vital group. Stratified sampling is the fix for that. You divide the population into these subgroups. They're called strata first. And then you draw a random sample from within each of those groups. And this table shows you exactly how that works. Just look at this population of healthcare workers. You can see nurses make up 84% of the whole group. Well, a proportional stratified sample makes sure that your final sample also has exactly 84% nurses. See how the percentages match? It perfectly mirrors the population structure. It guarantees that even those really small groups, like the physiotherapists at only 2%, are represented correctly. It's brilliant.
Okay, let's switch gears and go down that other path, non-probability sampling. Remember, the goal here is totally different. The researcher isn't trying to get a perfect snapshot of everybody. No, sometimes you need to talk to very specific people to understand a really complex issue. This is all about sampling with a purpose.
So the methods here are way more targeted. Convenience sampling is, you guessed it, studying whoever is easy to reach. Quota sampling is kind of like the stratified method we just saw. You decide you need certain numbers from different subgroups, but instead of picking randomly, you just go out and find people until you fill your quotas. Purposive sampling is when researchers use their own expertise to handpick specific participants, like experts in a field. And snowball sampling is fascinating. You find one person from a really hard-to-reach group and ask them to refer you to others, building up your sample like a snowball rolling downhill.
So we have all these powerful tools, but, with great power comes great responsibility. Because if your sampling is flawed, your entire study is built on a foundation of sand. It's simple. A bad sample will always produce bad data, period. And right here, we need to understand the huge difference between two kinds of problems. On one hand, you have sampling error. This is just the natural, expected, statistical variation you get from studying a sample instead of everybody. It's pretty much unavoidable. But on the other hand, you have sampling bias. And this is a fatal flaw. It's a systematic error made by the researcher that makes the sample pretty much worthless.
And bias can sneak in some really subtle ways. If you only use one language for a survey, you immediately exclude anyone who doesn't speak it. A researcher's own unconscious beliefs might lead them to approach certain kinds of people and avoid others. If you only collect data between 9 and 5, you completely miss the voices of all the night shift workers. These are the kinds of systematic flaws that can just sink a study.
This example just makes it crystal clear. Imagine you're trying to understand substance abuse among all high schoolers, but you only go out and talk to kids at a big sports event. Just think for a second. Who are you systematically excluding? You're missing students in drama or band, or kids who don't do extracurriculars at all. You might be missing the very kids whose substance use prevents them from participating. Your sample is fundamentally deeply biased. Look, if there's only one thing you take away from all of this, let it be this. The sampling method is everything. It is the absolute foundation of a study's credibility. If you don't have a sound sample, you're going to get flawed conclusions. It doesn't matter how fancy the rest of your analysis is. Garbage in, garbage out.
And that brings us to the final takeaway. From now on, the next time you see a headline about some new study, I want you to challenge it. Don't just accept the findings at face value. I want you to think like a researcher and ask the single most important question you can ask. Who did they ask? Because the answer to that question, well, it tells you everything you need to know about what the results truly mean.